Okay, this is the second example about factoring polynomials, which shows different situations comparing to the previous one. Remember that we need to start the exercise rewriting the polynomial 6x to the fourth plus 13x cubed plus 6x squared minus 3x minus 2 equals to 0. Because we are looking for the roots of the polynomial, which are exactly the same as the solutions of this equation. Now we follow the steps. In this case, we can't take out factors, and we don't have a special product nor a biquadratic equation. So we are going to apply the Ruffin's method until second degree. 6, 13, 6, negative 3, and negative 2. And we are going to look for the roots from the divisors of the absolute value of the independent term, which is 2. The divisors of 2 that are positive negative 1 and positive negative 2. Remember that we had two easy rules to figure out if 1 or negative 1 are roots of my polynomial. For the 1, we need to sum up all the coefficients of the polynomial, and the result must be 0. In this case, it's clearly different to 0 because we have big positive numbers here. For the negative 1, we need to do 2 additions of every other numbers. So we have 6 plus 6, 12 minus 2, 10, and this addition must be the same as 13 minus 3, which is 10. So yes, negative 1 is one of my roots, negative 1. I do the numbers. 6 times negative 1 is negative 6, plus 13 is 7, times negative 1 is negative 7, plus 6 is negative 1, negative 1 times negative 1 is 1, minus 3 is negative 2, times negative 1 is 2, minus 2, 0. But we need to keep going one more time with the Ruffin's method, because I've obtained a third degree polynomial, not a second degree polynomial. And on the other hand, I'm going to try again with negative 1, because we can have a root several times. If we check the rule for the negative 1, we have again 6 and negative 1. So 6 minus 1 is 5, which is exactly the same as 7 minus 2, 5. So it works. I'll do the numbers then. 6 times negative 1 is negative 6, plus 7 is 1, times negative 1, negative 1, minus 1 is negative 2, times negative 1 is 2 positive, minus 1 is 0. Now we have the quadratic equation that we need to solve. X is negative 1 plus minus the square root of 1 squared, 1, minus 4 times 6, negative 24, times negative 2 is plus 48, over 2 times 6, which is 12. So we have negative 1 plus negative square root of 49, which is 7, over 12. We obtain two solutions, one with a negative and the other one with a positive. Negative 1 minus 7 is negative 8 over 12, and negative 1 plus 7 is 6 over 12. The results are negative 2 over 3, simplifying the fraction dividing by 4, and 1/2, simplify the fraction dividing by 6. So we have a fourth degree polynomial with 4 roots. The first one is a double root, negative 1 from the Ruffin's method, and the other two ones from the quadratic equation are negative 2/3 and 1/2. Now we are going to factor the polynomial 6x to the fourth plus 13x cubed plus 6x squared minus 3x minus 2. And its decomposition is going to be a product of factors x minus the root, which means that we need to change the sign of the root. We have then x plus 1 twice squared, because the negative 1 is a double root, times x plus 2/3 times x minus 1/2. Remember that before finishing the exercise, we need to check the leading term, the degree of the polynomial, x to the fourth power, doing the multiplication. So x squared times x is actually x to the fourth power. But we need to check as well the leading coefficient. This is very important because when we multiply, we obtain x to the fourth power, not the 6. So we need to add it in front of the expression. And this is the result of my exercise. Summarizing, with this exercise, we've learned that it's recommendable to try Ruffini twice because we can have roots several times, and also to solve the quadratic equation because Ruffini doesn't work with fractions, only with whole numbers. So if you don't forget to place the leading coefficient in front of the expression, you're done. Thank you so much.